All right, we're live? Okay. Hi, everybody. My name is T.R. Bosworth, and this is Mark Darnell. We're both product managers at SUSE. We take care of SUSE OpenStack Cloud. And we're going to talk to you about OpenStack and software-defined all the way. So we're going to play a little bit of role activity here. I'm going to be the jack-of-all-trades admin, and Mark's going to be the OpenStack champion.
The superhero jack-of-all-trades admin.
Okay.
He's the stud.
Superhero. And so obviously, we're going to tell you about why it's so important why bother with software-defined infrastructure, obviously. You want to go fast, and we want to go fast too. So what does that mean? We're going to talk about doing software-defined infrastructure for networking, compute, and storage. And we'll talk about kind of where we came from and where we're going to. So SUSE has a blueprint for software-defined infrastructure, and this is a picture of it. At the bottom, obviously we have Linux. We provide a Linux enterprise quality distribution that has very stable APIs, and we have the ability to virtualize the compute with the hypervisor, storage with software-defined storage, and networking with SDN and NFV, as well as the native capabilities within OpenStack. So as you basically go up the stack, obviously OpenStack gives you very good APIs to be able to do software-defined networking, and then you can layer on things like Kubernetes and also cloud platform on top of that. So this is our SUSE picture blueprint. So let's start where we started with everything. So we kind of came with a legacy data center years ago that was consisting of mainframes. You had an admin for your mainframes, mini computers, maybe Unix-based, and then microcomputers with Windows and Unix. And then you had some sort of storage network infrastructure that was usually big box storage, and each one of these kind of islands have an administrator. So why don't you talk about the legacy to SDI and compute?
All right, so starting maybe 10, 15 years ago, we saw virtualization really start to come on in the data center. That was really the first thing to move into a software-defined storage environment. So what we saw, and we all know who the major player is in this space, we saw a commercial virtualization platform that really started to drive based off commodity servers and really follows one model of deployment, and that is commodity servers, cookie cutter, everything is virtualized. You've got one hypervisor. This is basically one nut fits all sizes. So TR, you have any questions or concerns about that? My superhero jack of all trades administrator, as I begin pushing this from an OpenStack perspective or a virtualization perspective into that data center, how does that work for you? Do you have concerns?
Yeah, so I had all these super specialized compute engines, and what about, are these commodity servers really fast enough to take care of this virtualization?
So there's two answers that we've got to that, and one is that we tend to follow, as opposed to a mainframe and mini market, we tend to follow more of a scale out versus scale up approach. Instead of adding more hardware inside a mainframe or a mini, we can simply add more boxes out there. Obviously, you're limited in the granule of what each individual server can support, but we have a real benefit with AMD, Intel, ARM, and so forth with cores. We have Xeons coming out these days, as an example, with 24 cores and a couple of socket server. You've got almost 50 effective processors inside that one box. So between the scale out of the individual PCs versus the cores, absolutely. We think commodity servers are fast enough.
So we talked about virtualization, but in my data center, I've got these special workloads that are tuned heavily for a database, or right now people are coming to me and saying, hey, I've got these high performance computing workloads, Kubernetes. What about that? Do we have some sort of a solution for bare metal?
So interestingly, or ironically, you've hit the real problem that we have with that historical or that legacy virtualization model. The ability to integrate multiple compute types in there. You really do tend to be locked into one type of virtualization with those. And that's why we end up, and if we pop onto the next slide, I think what you'll end up seeing is, we call some of these special flowers. How do you handle these special flowers? And the reality of the matter is, you have to take a little bit of a step back from that virtualization, maybe a couple of steps back towards where we came from, in terms of implementing or integrating bare metal into your environment. And that bare metal capability, done in OpenStack via Ironic, really allows you to implement Kubernetes, bare metal Kubernetes, HPC, and so forth, and then still have a single control plane managing and controlling all of those devices. And that is a critical differentiator between why something like an OpenStack exists versus some of the other commercial platforms that are available to you. So absolutely, I think we have a solution to that.
Cool. So let's say I've got VMware, let's say I've got KVM. Can I run more than one hypervisor using OpenStack?
Absolutely, that's one of the beauties of Nova, the ability to integrate multiple types of compute drivers in there and also have the networking of those devices linked together using, say, Neutron as well. All of those will plug and play together, also a critical differentiator between what's available on the commercial market.
Cool, so basically I can have one control plane that's kind of taking care of a heterogeneous infrastructure with hypervisor.
Absolutely, we've even seen some of our partners who bring legacy very high-end blade servers with their own hypervisor in them, and adding those drivers in really gives you a huge amount of flexibility, the driving factor being control from that one control plane.
Cool. All right, well let's talk a little bit about storage. I mean, what's going on with storage with software-defined network?
Absolutely, what we're seeing from a monetary perspective in the legacy storage market, and if you can pop back just to the prior slide just for a second so I can point out a box. The large box at the bottom is a historical fiber channel storage area network array. It is a total scale-up model, and what we're seeing with Ceph is, and SUSE's product says, is a scale-out model where once again we're leveraging commodity servers, open source software, and able to scale this storage, end up replacing some of the expensive switches, the fiber channel switches, because Ethernet tends to be a little bit less expensive, and so forth. So any questions or concerns about that as we end up moving software-defined storage into play?
Well, you know, are these still, I think I went forward, there we go. So I'm used to these big arrays having very special ASICs and FPGAs built into the array. I mean, with this new model with Ceph, I mean, how are we overcoming that? I mean, how do we?
Excellent question. Those ASICs and FPGAs historically have existed for a reason. That's your hardware acceleration. The ability to implement that via a straight core, general purpose CPU, can be a little bit more difficult. Now, the fact that you're throwing a lot more cores at it solves some of that problem. But another way that you solve that problem is by bringing a huge number of cores with direct hardware access across the PCI bus available to, say, accelerated code running on the bus without having to go up into kernel or even user space. GPUs are the real story there. So we end up seeing GPU-based acceleration for some of these RAID operations that are going on, RAID 5, RAID 10, et cetera, the standard XOR operations that occur. So absolutely, those cores, just like with the scale-out operations that we see within the compute space and the number of cores, same mechanism is used here. And as a hint, you're going to see the same story being used in SDN and NFV when we start talking about software defining the network plane momentarily.
Okay. So what about my switches? Have they changed as well?
So why did we end up moving from fiber channel over to Ethernet? I don't know how many of you have worked with fiber channel versus Ethernet switches. Each one of them tend to be linked together via the same type of fiber optic cable, but they all have their individual pluggable devices that plug into the switch. They're called SFPs or SFP pluses. These are different between fiber channel versus Ethernet. Each one of them, you've got your own pool of materials and your own costs for each one. Tends to be a real problem. The fiber channel switches also tend to be substantially more expensive and require a unique set of expertise. So by going into very fast Ethernet, between 40 to 100 gigabit Ethernet, you end up being able to rule out some of those fiber channel, two sets of inventory. Solves a lot of problems in terms of CapEx and OpEx, ongoing training, expertise, and so forth. Once again, consolidating down to a more uniform set of resources.
Okay, yeah, I could see that because, working with switches, you got to know this vendor's switch and that one.
Yep, absolutely.
And if you get it into a more homogeneous state, then it's easier to take care of. So what about my object and file servers? I know about block storage, but then I've got this object storage, I got file servers. What's that like in this new software-defined infrastructure?
Okay, so it looks like in the network diagram that I got from you, we're missing a couple of blocks there, so a little bit of a surprise on this one. Let's go back and think about what was really happening inside that large block array that was hooked up via fiber channel. That particular device exposes only block storage, so request a 512 byte block, across the bus it comes, that's what you get. The problem is that we have other types of storage that are at play in the enterprise. Object is one, Swift obviously is a pure integrated software-defined mechanism inside the OpenStack space, but then we also have file services. We have those historical file servers where I just need to go request this file name and get all the bytes back on it. The legacy data center model adds on servers that are file servers or adds on object servers that then access that block storage. So you have 3 different types of devices with generally 3 different types of administrators that all have to work with these. The beauty of Ceph, which is the OpenStack storage model or software-defined storage model, is that it supports all 3 of those protocols in one box on scale-out commodity hardware using consistent networking hardware as well. So it really does solve a huge number of problems that historically we've had to maintain a lot more people for.
Okay, so it sounds like I put in my Ceph cluster, I can do block storage, I can do object storage, I can do file servers, and it's one thing to take care of.
Absolutely.
Cool. Okay, I want to interrupt, you want to interrupt for a SDI
exactly.
commercial break.
All right, so next slide please. So, we've talked about the compute plane and what's happened there with commoditization. We've talked about the storage plane and what's happened there with commoditization and moving into a scale-out versus a scale-up model. Now let's move into 2 concepts that are happening in the network space. And this is a beginner-focused talk, so some of this may be a little bit elementary, but we're truly trying to make sure that this deck can end up being a reference for people when you're trying to refer to terms and how does this come into play in my data center. NFV is one of 2 major ones going on. You'll notice that the letters virtualization of network functions are called out, of course, in SUSE green because we're green. And that virtualization of network functions creates what are called VNFs. A VNF in OpenStack parlance is an instance. So what we're doing is we're taking a piece of network functionality out of maybe a dedicated appliance, we're moving it into an instance, so it's a DHCP server or a DNS server or a router or something like that, pushes down inside that piece of software and now runs as an instance. And you'll see a picture momentarily for what impact this has on the data center. There are 2 major pieces that you need to be aware of inside NFV in the market right now. And it's originally when we started off discussing NFV in OpenStack, there was one NFV. Within the last year and a half, this has changed into 2 pieces. One is enterprise, which are the fundamental functions I just talked to you about, say routers, firewalls, DHCP, etc. And those are fairly easy to do. The second one that is much more specific, and this will involve a lot of the technologies that you'll see discussed in the tracks here this week, this is Telco NFV. And the deal with this is because, especially when you start dealing with 4G and 5G technologies, they have to be drastically accelerated. All those functions used to be implemented in ASICs and FPGAs. So therefore, we're having to come up with unique and new types of software-defined networking acceleration in order to make those functions run faster, specifically to replace those ASIC and FPGA functions that you see mentioned here. And we will get into that a little bit more in a further slide.
Okay. All right, so we're back to our regularly scheduled program.
Right.
So let's talk about what our normal data center looked like, I don't know, 10 years ago. You can see, I'm very familiar with the top part here. We have a firewall, we've got a DHCP server, we've got a DNS server, and you worked with those. They were typically external appliances, and it was like easy for me because I knew it was great. That's what I had before.
All right, so let's pop to the next slide and see what happens. It's a very simple migration. Those icons that were in that top layer have now migrated down into the compute layer. So now instead of having dedicated appliances at this top, you've simply moved those functions into instances there. This picture is a perfect, I wouldn't say perfect, it's a very accurate picture of an OpenStack-based with Ceph as software-defined storage and then enterprise NFV running inside your data center. Okay? So now the question becomes, if we want to do telco, we may need to take another momentary commercial break here.
Oh, wait a second though.
Actually, sorry, I jumped ahead.
You jumped ahead.
I answered that question. Sorry,
He
Teal,
answered this question.
I stole your thunder. Sorry.
Anyway, what I was going to say is where'd my firewalls and everything go? Normally you had that appliance layer at the top. It got moved down into the virtualization layer.
With the corresponding CapEx and OpEx savings as well.
Okay.
All right, so now let's talk about the second piece. Realize that you can implement Telco NFV and Enterprise NFV in the same cloud. Arguably, you generally would not, and the reason why is if you're talking about telco virtualization or telco NFV, what you'll usually do is telcos are usually divided in two halves of the company. And it's a very much a generalization, but bear with me for purposes of this talk. We're going to split it into two halves. One is the enterprise or maintenance side, billing side, the other side is network side. I'm going to show you a picture coming up where we're injecting telco NFV functionality into this. All right. We're going to move quickly. We've got about 6 minutes left right now, and I'm trying to make sure we fit everything in here. So, we have 3 different technologies that you will see discussed at OpenStack Summit this week. One is, let's see, OVS DBDK. So Intel drove the introduction of a technology, Open vSwitch, injecting a data plane development kit, acceleration technology, basically moving stuff up into user space. You all will have access to these slides. I know you can download them. So real quickly, the green stuff is OVS DBDK. This would be fast east-west traffic, virtual machines on the same machine talking to each other, basically at line rate. Okay, so that's OVS DBDK, pure virtualization. And we'll cover a summary of this momentarily. The second one is SRIOV. You need a specific type of network card to do SRIOV, all right? And that exposes a semi-physical, semi-virtual up into, in this case, instance 3 of the instances that are running on this node. And then the third mechanism you probably heard discussed in one of the keynotes this morning, that's PCI pass-through. That is basically allowing a particular physical device to get mapped fully into the memory space of a virtual machine or instance. These 3 models cover the major acceleration technologies that are available with NFV, telco NFV these days. Let's blast on to the next slide.
Okay, yep.
So we've got that summary. You want to wrap that or?
Yeah, so basically this is kind of re-emphasizing what Mark was saying. You've got the pure user space, OVS DBDK, you've got hybrid, which is SROV, and then you've got hardware-centric, which is PCI pass-through. Those are the 3 classes or 3 types of network acceleration. So, another commercial break.
All right, so quick coverage on SDN. This is the second technology that you'll see covered here. So now we still have our enterprise NFV, we have our telco NFV, but now you'll notice some green dots that have been added to this picture. So the next slide was TR asking, hey, what are all those green dots for? And my answer to him is, this is your new job. You now have to manage pushing policy to all of those green dots because each one of those green dots is an open virtual switch that's running on these boxes. So now no longer do you just have 2 switches in the top layer in your network layer, you've also got a bunch of switches in the middle layer that have to be managed too. So that's going to be a crap load of work for you, right?
It seems like it's going to be a lot of work. How am I going to do this?
Well, the nice thing is we have OpenStack Neutron, which at its core is a software-defined network. Neutron is an SDN controller and will push policy. The problem is unless you begin injecting a lot of interesting drivers that may or may not be fully compatible with each other into Neutron as an ML2, you do not get control from Neutron of both the network layer switches and the OVSs in your compute layer. SDN solves that problem. So, list off some vendors real quick. We've got Cisco ACI, we've got VMware's NSX, we've got Juniper's Contrail, we've got Nuage. In the open source space, we have Open Contrail and we also have Open Daylight. All of those are SDNs that will end up managing and pushing policy to both switches, physical switches, and your virtual switches. So that makes your life a whole lot easier. You can manage your entire network plane from one box.
Oh, okay, that's much easier then. I can deal with that.
And we can just blast right on through that one.
Okay. All right. So let's wrap up. We've talked about how we can change the world with software-defined networking on compute, with virtualization and also ironic bare metal. We've talked about storage, how Ceph unifies your open storage capabilities and allows you to do software-defined networking with storage. We've talked about NFV SDN integration, that it gives you that really nice way to have a single thing that's taking care of your infrastructure with software-defined networking. And with OpenStack, it kind of bridges the world between your traditional IT environment where you were coming from. You can run and manage that, your typical ERP apps and different things, as well as your new agile IT world. So things that are happening old and new can be managed and controlled with OpenStack. And you can use software-defined networking to basically simplify that whole infrastructure. And so that's pretty much, you're getting better agility, you're getting faster time to market, and you're simplifying your life.
All set.
And I think that's what we have. That's all we have today. And thank you for your time.
Appreciate it. Thanks.